In this problem, we have a 2012 AMC 12B, problem 21. Square AXYZ is inscribed in an equiangular hexagon ABCDEF with X on BC, Y on DE, and Z on EF. Suppose that AB equals to 40, and EF equals to 41 times square root 3 minus 1. What's the side length of the square? So xy in this case will be the side length of the square we want to find. Now, we can, without loss of generality, assume that y coincides with d and CD is parallel to AF as before. In which case, we have BC equals to EF. And this will equal to 41 times square root 3 minus 1 as given in the problem. This is under the precondition that y coincides with d. So just suppose that y coincides with d. Then we'll have that square AXDZ inscribed in equiangular hexagon ABCDEF. Well, in this case, we will have X on BC and Z on EF. And then we can know that if we let the side length to be S, so like AX equals to XY equals to S, and then we can let, you know that X is on BC, right? So we can let BX equal to U and CX equal to V. And then in this case, we can let angle BXA, which is this angle, to be theta. And then angle BAX would be 30 degrees minus theta. It'll be 60 degrees minus theta. So now we can use an equation in triangle ABX. We have 2s divided by square root 3 equals to u divided by sine of 60 degrees minus theta equal to 40 divided by sine of theta. We also have angle CXD, which is this angle. Remember that right now we have y and d coincides right now. So d will actually be a vertex of the square. So angle CXD will be 90 degrees minus theta. And CDX will be theta minus 30 degrees. So then we have in triangle CDX 2s divided by square root 3 equals to v divided by sine of theta minus 30 degrees equals to CD divided by cosine of theta. Now, we know that BC would equal to U plus V equals to 41 times square root 3 minus 1. From equations 1 and 2, these two equations here, we'll have 41 times square root 3 minus 1 equals to 2s divided by square root 3 times sine of 60 degrees minus theta plus plus sine of theta minus 30 degrees. So simplify this to get 2s divided by square root 3 times square root 3 minus 1 divided by 2 sine theta plus cosine theta. From equation 1, we have s times sine of theta equals to 20 square root 3. S times sine of theta equal to 20 square root 3. So s times cosine theta will equal to square root of s squared minus 3 times 20 squared. Thus, simplifying the equation will give us 41 times square root 3 minus 1 equals to square root 3 minus 1 divided by square root 3 times 20 square root 3 plus s squared minus 3 times 20 squared. So you have 3 times 21 squared to s squared minus 3 times 20 squared. So we notice right away that s is in a Pythagorean triple. Not 20, 21, 29 is a Pythagorean triple. So we can get that s equals to 29 square root 3. So the answer to this problem is A.